Welcome in, everybody, to week 4 review video time. This is so obviously you're in your 5th week, but this is the 4th week of these videos. This will be covering chapter 4, calculating the derivative. This will be a little bit more of a condensed version of the previous videos you saw in the past. I'm not getting a ton of viewership on these videos, so I am kind of saving some of my time and maybe shifting it elsewhere until I see more participation. But we will still cover some of the same topics that we have in the past as far as what we do each week. This week we're going to be covering 4 problems, one from each section, 4.2, 3, 4, and 5. 2 of them are from the homework and 2 of them are from the quiz. And we will just go through them, solve them. And again, remember, if you have any questions about either of these problems or anything else, feel free to set up an office hours appointment with me via email, or just email me, and I'll see if I can address it there. The first problem we have today is in the section about quotient rule and product rule, and it's a word problem. It states that the total cost in hundreds of dollars to produce X units of perfume is given by the function C of X equals 3X plus 2 or X plus 4. Find the average cost for each production level. A, 10 units, B, 20 units, C, X units, and then D, find the marginal average cost. So we want to find the average cost. This is going to be the total cost divided by the number of items that we have, which we are given that C of X is the total cost, and then X units will be the number of items. And I just want to rewrite this down here so we can look at it when we need to. So remember, C of X equals 3X plus 2 over X plus 4. All right, we should have everything we need right here then. So A is 10 units. So we just plug this into our average cost function. This means we do C of 10 over 10 units. This equals 3 times 10 plus 2 over 10 plus 4. And then this is all over 10. This equals about 0.2286. And remember that this is a key fact. We are in hundreds of dollars here. So this is an easy way to make a mistake on a problem, is to write the units incorrectly. So if we have 0.2286 hundreds of dollars, this means that we're at $22.86. So $22.86. We can just multiply by 100 to see that. For B, this is the same process, just a different number. So 3 times 20 is 2. 20 plus 4, all over 20 units. And this is going to be cut right to the chase, 0.1292, which gives us $12.92 by the same logic above. And then C, we have X units. So without getting too torn up by the letter, we're just going to do the same thing we would normally do. C of X over X units. We have 3X plus 2. So this is just the function C of X. And then we divide it by X. So this X just multiplies through on the bottom. And we get 3X plus 2 over X squared plus 4X. So for A, we have $22.86. For B, it's $12.92, and this is our answer for C. This is the same as C bar of X. We're going to call it that for now. Let's see if I can squeeze this in here and make enough room for part D. Part D is the one that will take the longest, most amount of work. Let's make this small. That looks good. Let's do part D. So part D, remember that the marginal average cost is the derivative with respect to x of the C bar function. So it's C bar prime of x. So we just take this function here. We say we want to find the derivative of 3x plus 2 over x squared plus 4x. This is where we use the knowledge that we've gained in this section about the quotient rule. So the easiest way for me, remember that the quotient rule, let's write this up here. So the quotient rule, it says derivative with respect to x of some function over another function. We do low times, so this is the bottom, or the top times the derivative of the bottom. Actually, it's the other way around. I think it's easier to remember the other way around. So we do the bottom times the derivative of the top minus the top times the derivative of the bottom. And then this is all over the bottom squared. So there's kind of like a little moniker that, or a slogan that you can think of that people use to remember this, and it's low D high minus high D low, square the bottom, and away we go. So you have low G of x, so let's switch to this thing. So this is low times D high, so the derivative of the top, minus high times D low, so the derivative of the bottom, and then you square the bottom, and the away we go is you're done, right? That's what that means. I don't know if that helps you. I don't use it anymore, but there's nothing wrong with using it. Okay, so what I like to do, if you want to be extra sure of yourself, is to just write f of x. Because in this formula, we need f of x, g of x, and then both of their derivatives. So I'll write f of x, and I'll make that 3x plus 2. I'll write g of x over here, and that will be x squared plus 4x. And then I also need f prime of x, so I just do the derivative quick, and I see that it's 3. And then g prime of x, and I see this is going to be 2x plus 4. And that's just using the power rule. Okay, so I have all those things that I want. So this derivative is going to equal, so I'm going to go, so low, I'll start here, g of x, d high, f prime of x, minus high, that's f of x, d low, g prime of x. So that's the order I'm going to go in. So we'll go x squared plus 4x times 3 minus I d low, 3x plus 2 times 2x plus 4. Don't know what happened there. And then we square the bottom. So the bottom is g of x, so this is x squared plus 4x squared. And now all we have to do is simplify the top. And I'm going to skip a couple steps because this is just algebra at this point. What we end up with on the top is negative 3x squared minus 4x minus 8. And then we'll leave the bottom the same. Oh, what did I do? I put the squared here. It should be on the outside. That was silly. Okay. Leave the bottom the same, and we're good to go. So this is the solution for D. All right, this is actually the longest problem that we're going to do today. The other ones are a little bit more brief. but it's a nice little application of the quotient rule. All right, section 3. This is actually this doesn't involve the derivative. This section is on the chain rule, I believe, and I think the concept of this problem, the motivation behind this problem, is to get you to understand how a function inside of another function works. So the function or the problem states, suppose the demand for a certain brand of vacuum cleaner is given by d of p equals negative p squared over 100 plus 500, where p is the price in dollars. If the price in terms of the cost, c, is expressed as p of c equals 2c minus 10, find the demand in terms of the cost. So what we're saying is we have two functions here. There's d of p, which is the demand in terms of price, and then we have p of c, which is the price in terms of cost. And we want to bridge the gap and get the demand in terms of cost, right? Put these things two together somehow and get the demands in terms of cost. Well, this is fairly straightforward. What we do here is we know that d of p, this is a function of p, but if we take p as a function of c, what we can actually write this as, you can think of this as d p of c, right? So remember, p of c is equal to 2c minus 10. So wherever we see a p, this equality here says that wherever we see a p, we can just put in 2c minus 10. So dp of c equals negative 2c minus 10 squared over 100 plus 500. Now notice that this is a function whose only variable is c. That means this function is in terms of c, and c is the cost. So we have found a function, a representation for d in terms of c. Now the rest of this is just simplifying. So if we actually do this multiplication, we're going to get negative, 4c squared. Let's do it like this. Minus 40c plus 100. So this is the square of the binomial in there. 100 here. We can cancel out a 4 here. So 25, 1, 10, 5. We get, distributing that negative sign through, we have negative c squared plus 10c minus 25 all over 25. And now I want to change 500 into something that I can add to this term. So I need to write it as something over 25 as well. The way that I do that is by multiplying by 25 over 25. So that ends up being 12,500 for 25. Now I can add them together. I have negative c squared plus 10c, and then this number is plus 12,475 over 25. That's it. So all you're doing here is plugging in 2c minus 10 for p. All right, let's move on to the last two problems. The last two problems are just finding the derivative. These were from the quiz, and the first one involves an exponential function, and the second one involves an exponential function and a logarithmic function. Both of these involve quotients. So we're going to do the same sort of technique that we did the first time. And we're going to write out what f of x is, what g of x is, and then find both of their derivatives, and then we just write out the result. We have f of x, that's going to be the top. g of x is the bottom. So remember so this is f prime of x. The derivative of e to the x is the same as the function itself. It doesn't change. So that's kind of the unique thing about e to the x. Now g prime of x, this is just using the power rule. It's just 2. So this should be fairly simple. Now we do, again, we're going to go in this order. Let's write it in red. From here to here to here to here. And then we square the bottom. Okay. So we do 2x plus 1 times e to the x minus e to the x times 2, so 2e to the x. This is all over 2x plus 1 squared. So we can pull an e to the x out of the top, and we have e to the x times 2x plus 1 minus 2. And we'll leave the bottom the same. And then these will cancel into each other. We'll be left with a minus 1. E to the x times 2x minus 1 over 2x plus 1 squared. So not too bad. All right, finally, the last one. This is just like the same. It's just like this problem, except the bottom function is different. So f of x again, e to the x, f prime is going to be the same. Now the bottom function, g of x is natural log of x, and we know from our book that the derivative of natural log of x is 1 over x. Using the same technique, I'll write it out one more time, going this way, that way, that way. We're going to do natural log of x times e to the x, and then minus e to the x times 1 over x. This is all over natural log of x squared. So we'll pull out an e to the x to make it look nice. And here we have natural log of x minus 1 over x. And then on the bottom, should be careful when I write this. On the bottom we have natural log of x squared. So with that, when I don't write those parentheses there, I'm saying this is the natural log of the number x squared. When I say that, that means that I can pull the 2 out in front of the natural log. But I'm not really squaring the number inside of the natural log. I'm squaring the whole function itself. So those parentheses are very important there. All right, now one quick note here. This is fine. So this is a solution. The book writes the solution as this. They write, see, x e to the x natural log of x minus e to the x over x natural log of x squared. And this is just, what this is it's this thing here. So let's just copy paste it. So it's my solution. Let's make it a little smaller. And what they did is they saw the 1 over x in there and they didn't like it. So they multiplied by x over x, which is just 1. You can always do that and not change the value of the fraction. And this ended up doing was it got rid of the 1 over x in the numerator. And you can check this. Maybe I'll write that. You can check this and verify that it is the same thing. All right, that's going to do it for us today. If you'd like to see any other problems, please let me know, and we can do them in office hours, or you can send me an email. Have a good day, everybody.